Attention, at this time, we need 8th grade art enrichment, the CBIP, Career-Based Intervention Program students, to please go to the main gym now for your picture. Please wear your mask over your nose and maintain social distancing. Thank you.
All right, so there's the answers from yesterday, so if you haven't submitted, please do so. And we'll get started with today's information. And we're moving on to section 5.5. Oh, there we go. We're gonna work with some imaginary numbers. How about that? Imagine that. So if you would, you can close down your computers now and get some notes out. Oh, you submitted? That's fantastic. So, complex numbers and roots. We're going to work on these guys right here, define and use imaginary and complex numbers, which most of you should be able to do pretty good with, and we're going to keep solving quadratic equations. This we've been doing all week. We're going to do complete the square, but we're just going to get a little different type of answer. Today's lesson can be summed up in one thing, and that is this: the square root of -1 is equal to I. The square root of -1 is equal to I. So most of the time, if you put the square root of a negative number in your calculator will say non-real or error. If you have a calculator handy, you don't have to dig it out, but if you have one handy, try the square root of -4. So if you put the square root of -4 in there, most likely it's going to say non-real or give you an error even. Okay? But we're going to learn today that that is not a real number, but it is an imaginary number. So this does work out to be the square root of -1 times the square root of 4. Well, I just told you the square root of -1 is I. Square root of 4 is 2. So this simplifies to 2I. So we are introducing the square root of -1, which is I. And for the most part, that's all there is for today. Gotta practice them now. Lots of practice with them. Make sure everybody sees and has an idea what's going on. But that, my friends, is about it for today. Now, there is one other thing I want you to be aware of. If we have I squared, okay? So if we have I squared, that is equal to -1. So sometimes we'll be getting into that as we get I squared. So I squared is -1. So really the main thing, if you got it in your notes right now, is this guy right here. Let's simplify a couple radicals that are negative. Remember, these are non-real now. We're working with imaginary numbers now. Imagine that. Or also sometimes we can call them complex numbers. I already went over this right here. Let's try a couple and simplify some. We've already been simplifying radicals quite a bit, but notice all of these have what under the radical? They're all what? Negative. Okay. So for these first ones, we'll break it down really in a lot. This is going to be 5. Whoops, there we go. How about that? Let's see if we can make that happen again. Come on now. Please cooperate. See if it does now. Okay. We're going to have 5 times the square root of -1 times the square root of 121. Notice I've just kind of taken the square root of -1 out. Now, you don't have to do that. I'm just doing it this time so you can see how we're getting that, how we're breaking stuff down.
At this time, we need the JTC, Job Training Coordination Group, Marketing, and Voice Blue. Please go to the main gym for pictures. Please wear your mask.
Square root of 121 is 11, so this is going to end up being 5
At this time, it is for JTC
times 11
Group, Marketing, and
times
Voice
I,
Blue.
because the
Thank
square
you.
root of -1 is I, so this really ends up being 55I. Now let's be truthful. There's really nothing that big of a deal here, is there? It's what we've been doing. We just throw this square root of -1 in there. What do you think here? It's really gonna be 2 times the square root of -1 times the square root of 36. Well, we know the square root of 36 is 6. 6 times 2 would be 12. Square root of -1, I. See what you can do with 96. I'll give you a little hint there. 96. I think 16 goes into 96. You have a calculator handy. 96 divided by 16. I think it does work. See if you can simplify that. Is it 16 times 6, anyone? I think it is. Okay. So now we still have that negative out front. We're gonna have the square root of -I. We're gonna have the square root of 16, and we're gonna have the square root of 6. So let's simplify some of that. Well, 16 right here is 4. That's gonna be I, so we're gonna negative 4I square root of 6. How are we doing? Is it making sense to you? The 7 of you that are in class today? 63. I think that's 9 times, so we're gonna negative 1/3 times the square root of -1 times the square root of 9 times the square root of 6. So now let's simplify. We're gonna simplify the square root of 9 to 3, but 3 times 1/3 would be -1, but that's I. So we're gonna have a -I square root of 6 is what that guy ends up being. -I square root of 6. Now we don't need to put 1 in front of the I there. It's -1I, and it's understood to be just like any other time. Square root of 12. Square root of -12. How are we gonna break that one down? Well, square root of -1, of course, that's I. Square root of 4, square root of 3. So this guy ends up being 2I square root of 3. Imagine that, imaginary numbers. What's the only thing really new today? Square root of -1 is I. That's it. Make it in simple terms. Now, we're gonna put these into some equations also. So let's take that and take a look at some of those. I'm gonna solve this first one for you, and then I'm gonna let you try to solve the other 4 here in a second. No different than what we've done in the last couple days. What am I gonna do? I'm gonna take the square root of both sides. So now I'm gonna have x is equal to, of course, when I take square root, I need plus or minus. And now the square root of -144, and you might, you don't need to break them down as much now if you're starting to pick up on it. What would that be? Square root of 144 is 12. We have the negative, so this is gonna be 12I. See what you can do with let's come down to this one. This one's probably pretty easy right here. Square root. Give you a second. And then go ahead and see if you can do the other 3. Beautiful sunshiny day today, huh?
It's snowing, it's
It's all Ohio. Northeast Ohio in November. I think they said 60 degrees later on this week. Thursday and Friday. I think this first guy right here is gonna be what? 6I, isn't he? Or some of your teachers going over Google. Yeah. So you guys are getting that, you're figuring it out. I don't need to do it, do I? It's pretty simple, just join, right? Change your background. I had mine in the clouds yesterday when we were doing our training. Put myself in the clouds. Did you get see that, changeable backgrounds. Anybody mess with that one, who's doing it for you, what classes?
So far,
Every class, except for this one.
I haven't done any more classes yet.
All right, take the 25 over here, that's gonna be negative, I'm gonna have x squared equals negative 25 over 9. Those happen to be perfect squares, don't they? So x is equal to plus or minus. Taking the square root of both these, I'm gonna get 5i over 3. Negative 25 would be 5i over 3. How are we feeling there, okay? 90, take that over and divide. X squared is going to be equal to negative, what's negative 90 divided by 5? Is that 24? No,
No, 23.
20, no, it's not 23. Oh, please help me. 90 divided by 5, I have a brain dead. Get it, Hannah?
18.
18, that's better, yeah. Negative 18, take the square root there. X is equal to plus or minus, I think this is gonna be 3i square root of 2, because 9 comes out as 3, right? 9 times 2. And the square root of negative 1 is our I. And there we have it. We're down to this last one over here, 48. X squared equals negative 48. Take the square root of both sides, 40, I think 16 times 3. I think so. So x is going to be plus or minus 16 times 3. I think that's going to be 4i square root of 3. 4i square root of 3. Roger that. Is everybody good? Everybody feel okay about simplifying those? And we put some in the equation. Last thing today is we are going to solve a couple. Those are just complex numbers. We'll talk about those in a little bit. I'm not going to go through that. Here we go. We're going to complete the square on this guy right here. We're going to complete the square. Set it equal to 0. So we're going to have x squared plus 10x. Take that over equals negative 26. Same thing we did yesterday. Is everybody on board? So I think you'll find this. Listen, folks, we're not doing anything different. The whole thing revolves around getting negative square roots. All right, so half the term, middle term's 10, right? Half of it's what? 5, squaring it would be 25. So we're gonna add 25 on both sides. And what did I create here? None other than a perfect square trinomial. Always x, always that sign, always half the middle. Now, here's the only difference from the last 3 days and today. What am I getting over there? Not 1, but negative. I'm getting a negative number on that side. So now when I take the square root of both sides, I'm going to get x plus 5 equals plus or minus. What is the square root of negative 1? None other than I. I'm going to take the 5 over. I'm going to get x equals negative 5 plus or minus I. Now there are two solutions here. They are both complex. Negative 5 plus I and negative 5 minus I. Okay? Those are called complex conjugates. They come in pairs. When we have complex numbers, they come in pairs. My friends, there's not that much new here, is there? Now, what's going on with this parabola? Well, if we were to graph this parabola, okay, on the Cartesian, if our had our little XY coordinate here, and we were to graph this guy, he's gonna look something like that. Okay? Now that parabola has complex roots, which means what? Which really means it never crosses the x-axis. Look at my parabola. It doesn't cross the x-axis. Here's my x-axis. When I have complex roots, my parabola doesn't cross, which tells us that. So if we were to graph this in our graphing device, it wouldn't cross the x-axis. And that's how we get complex solutions. Non-reals. Square root of -1 is I. Exciting stuff, I think. For the most part. All right, take a shot at this guy right here. See how far we can take. See if we can get there. Complete the square, set it equal to 0, complete the square. Get the x squared and 4x on one side, and take the 12 to the other side, becomes negative. Got to figure out what makes the perfect square trinomial now. Factor both sides and simplify. Middle term's 4, half will be 2, squaring would be 4. Adding 4 to both sides. I've got my perfect square trinomial, always x, always that sign, always half of that middle term. Looks like I'm gonna get -8 over here. Taking some square roots, I'm gonna have x plus 2 equals, simplifying the square root of -8. It comes out to be 2i, square root of 2. Finish this up, take the 2 over, comes -2, plus or minus, we need that plus or minus there. 2i, square root of 2. Remember, these complex numbers come in pairs, so there'll always be 2 of them. One plus and one minus with the imaginary part. The real part always goes first. The real part always goes first, so the numbers go first. Now the square root of 3 is still a real part, but the part that has the I with it is the imaginary part. So all we've done was complete the square. We're getting the exact same thing we've done for the last 3 days, except over here, we're getting a negative number. That's all this has changed. Does this parabola cross the x-axis? No. If we were to graph this guy right here, he does not cross the x-axis. Last thing, we're gonna move on to the conjugates. So we're always gonna have a pair that come together, -5 plus I square root of 10, -5 minus I. They are called complex conjugates, okay? They come in sets, they come in pairs. There's always a pair of them, complex conjugates. I'm gonna ask you a couple simple questions here on this. And you can hopefully, most students say, give me a whole bunch of those. So if we have 8, notice the real parts first. This is the real part. This is the imaginary part because it has what? I. So if I have 8 plus 5i, its conjugate's going to be 8 minus 5i. How do you like that? How many of those went on the quiz?
Whole lot.
A whole lot. But remember, the real part needs to be first. Is this the real part? Yep, here's the imaginary part because it has the I with it. What's its complex conjugate going to be? 3 plus 6i. Oh my goodness gracious. Like stealing candy from your brother after Halloween. That's pretty easy stuff right there. Let's try another set. We all should be able to shout it out. What's it going to be? 9 plus I. I'm throwing you a curveball here. Because the real part's not first. So before you tell me the conjugate, let's put the square root of 3 is the real part. So we're going to rewrite
During
this.
the interruption, at this
Square root of
time,
3.
we need the Cornhole Club,
Plus I.
Fellowship of Christian Student Club, to report to the main gym now for your pictures. Please wear your mask over your nose and maintain social distancing. That's the Cornhole Club and Fellowship of Christian Students. Please go to the main gym now for your picture. Thank you.
So the real part needs to be first, everybody understand that, so now what's it gonna be? Square root of 3, minus I, there's your conjugates. Woo-hoo! How do we feel about them apples, everybody good? Spectacular. We'll work on that another day, and there you have a couple of problems to have some fun with. 2 through 17 on that page.